In this video, we will be looking at section 2.3, which covers modeling with linear functions. A phone company has a cell phone data plan where a company pays a flat monthly fee and then a certain amount of money per gigabyte of data used on their phone. If a customer uses 2 gigabytes, the monthly cost will be $37.80. If the customer uses 4.5 gigabytes, the monthly cost will be $66.30. We want to find a linear equation for the monthly cost of the data plan as a function of g, the number of gigabytes used. So we want this to be a function of g. So this g is going to be our input. So normally where we put an x, it's going to be this g value. So they gave us a couple pieces of information. When we use 2 gigabytes, the cost will be $37.80. So that can be represented by the order pair 2, 37.80. We also know if the customer uses 4.5 gigabytes, so 4.5, then the monthly cost will be $66.30. So that's nice because we have 2 points. That means we can find a slope. And since we're finding a linear equation, we definitely need a slope. So let's start by finding that slope. Our slope m is equal to y2, which is 66.30, minus our y1, 37.80, over x2, 4.5, minus our x1 of 2. 66.30 minus 37.80 is 28.50. And that's divided by 4.5 minus 2 is 2.5. And that is equal to 11.40. So now what we have is a slope. What I don't have is a y-intercept. So I need to keep going. Let's try using y equals mx plus b and see how that goes. I'm going to use this first point, 2, 37.80, because I think it'll be a little bit nicer. We have 37.80 is equal to our m, which is 11.40, times our x value of 2, plus b. So 37.80 is equal to 22.80 plus b. And if I subtract over the 22.80, I get that b is equal to 15. So I now have an m value and a b value. Those are the 2 pieces of information I need to write a linear equation. So they want us to write it in the form where g is our input and we want to write a function about the cost. So let's say the cost c for using g gigabytes, so c of g is equal to, my slope was 11.40, my input was g gigabytes, plus 15. Now plans like this actually do exist. In fact, my husband and I are on a phone plan where we have to pay, I think it's $17.50 per phone per month. That's just the upfront cost. So for both of us to have them together, it's like $33, I think, $35. It's somewhere in there. But we pay $10 for each gigabyte, and that gives us the cost of our plan. So this is actually fairly reasonable. Then we want to use our equation to find the total monthly cost if 7 gigabytes are used. So they're telling us we're going to use 7 gigs. So the cost for using 7 gigs is equal to 11.40 times 7 plus 15. And that turns out to be $94.80. So the cost of using 7 gigabytes on this phone plan is $94.80. We're going to do one more thing with these models. You're choosing between two different window washing companies. The first charges $5 per window. The second charges a base fee of $40 plus $3 per window. How many windows would you need to have washed for the second company to be preferable? What we could do is make a table and just see how long it takes for them to be equal. There's nothing wrong with that. But since we're working on linear equations, let's see what we can do with this. So our first company, we'll call them F. Company F washes windows, and if we have an input of W windows, the cost that we're going to pay is $5 per window. So if we take 5 times the number of windows washed, we will get the total amount that the bill will come to. The second company, we'll call them G, washes windows, and their cost is $40 up front plus $3 per window. So it's cheaper for each window, but we still have to make up for the fact that we paid $40 up front. So if we start really, really low on our numbers, say 1, 2, 3 windows, we can see that our first company is way cheaper. We want to know how many windows it would take for the second company to be preferable. Well, if you think back to the last section, we were talking about finding the intersection of two equations. If we find the intersection point of these two, that will tell us when the costs are equal. And then we know that after that is when the second company will be cheaper. So let's see if we can figure out where these two company costs are equal, and we'll go from there. So if the costs are equal, then we can set their expressions equal. 5W is equal to 40 plus 3W. I can subtract the 3W over, and I get 2W is equal to 40. Dividing by 2, we get W equals 20. W is representing the number of windows. So what this is saying is that 20 windows, they are equal. So if we want the second company to be preferable, we need them to wash more than 20 windows. If you have them wash more than 20 windows, it will be cheaper for you to use the second company than it would be to use the first. Anything less than 20 windows, it's cheaper to use the first company. If you get exactly 20 windows washed, it doesn't matter either way. We are getting the same cost out of it. And what's kind of interesting is I stopped after finding just W. In the past, when we were working on a question like this, I found the quote-unquote Y value as well. But I don't really need to here because I was just looking for the number of windows. I can show you that they're equal, that the costs are. If I were to plug in 20 windows into the first expression, that would be 5 times 20, which is 100. So it would cost $100 for the first company to wash 20 windows. And for the second company, it would be 40 plus 3 times 20, which is 40 plus 60, which is also $100. So both companies are the same at 20 windows. It's cheaper for the first company if you do fewer. It's cheaper for the second company if you do more.